Hello, in this lecture we will find the length of chord AB. In the drawing we have a semicircle. Inside this semicircle we have three circles. Those two circles are identical and the middle circle is tangent to this semicircle at point O. Point O is the center of this semicircle and point C is the center of the middle circle. And we know that PQ, that is actually the diameter of the semicircle, equals to 8 units. And the diameter of any circle is twice as large as the radius. So if PQ, that is the diameter of the semicircle, equals to 8 units, then the radius of this semicircle will be equal to 4 units. That is to say, the radius PO of the semicircle will be equal to 4 units, and the radius OQ will be also equal to 4 units. Likewise, the radius OX of the semicircle equals to 4 units. But OX is not only the radius of this semicircle, but it is also the diameter of this middle circle. So we know that the diameter of this middle circle OX equals to 4 units. And the diameter is twice as large as the radius. So the radius CX of this middle circle will be equal to 4 over 2, that is to say it will be equal to 2 units. And OC, that is also the radius of this middle circle, will be equal to 2 units. We will define the center of this small circle as point M, and then we will join together the centers M and C. M is the center of the small circle and C is the center of the middle circle. So we will join together the centers M and C by a straight line. Actually, MC is the distance between those two centers, and the small circle is tangent to the middle circle at this point. This is the launch point of the two circles, and MY, it is actually also the radius of the small circle. We will define it as R. And CY is the radius of the middle circle, that is to say it equals to 2 units. So in total, the distance between the centers of those two circles, it equals to R plus 2. Whenever you have two circles with an external length between them, like in this drawing, then the distance between the centers of those two circles will be equal to the sum of the lengths of their radiuses. The radius of the small circle is R and the radius of the middle circle is 2. So in total, the distance between the centers of those two circles will be equal to R plus 2. Then we will define the touching point between tangent PQ and this small circle as point N. Point N is actually also the point, the point of tangency of tangent PQ with this small circle, and we will join points M and N together by a straight line. Actually, MN is the radius of this small circle, that is to say it equals to R. And actually this radius, MN of the small circle, is drawn to the point of tendency, that is to say it is drawn to point N. That is the point of tendency of tangent PQ with this small circle. Therefore, we have a rule that whenever a radius is drawn to the point of tendency, then the tangent will be perpendicular to this radius. That is to say, the tangent PQ is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we have the radius CO of the middle circle is drawn to the point of tangency, that is to say it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. And because of the fact that the radius CO is drawn to the point of tangency, then the tangent PQ will be perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, then from point M, that is the center of the small circle, we will draw perpendicular to CO. Okay, so this is a perpendicular, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees, and we will define the touching point of the perpendicular from point M to CO. We will define the touching point of the perpendicular from point M to CO as point D. Point D is the touching point between the perpendicular and CO, and this point will be defined as point E. Then I will draw again this drawing with the quadrilateral MNOD and with the right triangle MCD. And we also know that AB is perpendicular to PQ. So I draw again the quadrilateral MNDO and the right triangle MCD, and we have, so we know that AB is perpendicular to PQ, and we have a rule number one. Rule number one states that corresponding angles between parallel lines are equal to each other. So I will read rule number one again. According to rule number one, corresponding angles between parallel lines are equal to each other. So we know that AB is parallel to PQ. So AB is parallel to PQ, and those two angles are two corresponding angles that are located between the parallel lines AB and PQ, therefore they are equal to each other. So this angle equals to 90 degrees, and it equals to this angle that is actually angle CEY. I will repeat again, those two angles are defined as corresponding angles, and they are located between the parallel lines AB and PQ, therefore they are equal to each other. And this angle is 90 degrees, and this angle is angle CY. That is to say, the angle that equals to 90 degrees equals to angle CEY according to rule number one, that corresponding angles that are located between parallel lines are equal to each other. Those two corresponding angles, 90 degrees and angle CY, are located between the parallel lines AB and PQ, therefore they are equal to each other. That is to say, 90 degrees angle equals to angle CY. So angle CY, this angle is the right angle, that is to say, it equals to 90 degrees, according to rule number one. Likewise, those two angles are corresponding angles, and they are located between the parallel lines AB and PQ, therefore they are equal to each other. So that is to say, this angle is a right angle, it equals to 90 degrees, and it equals to this angle that is actually angle CEB. Angle CEB, and they are equal to each other according to rule number 1, that corresponding angles between parallel lines are equal to each other. So we actually found out that angle CEB equals to 90 degrees according to rule number 1. That is to say, this angle CEB equals to 90 degrees. It is a right angle. Okay. So actually we found out that those two angles are right angles. Okay. And we will focus on quadrilateral MNOD. This quadrilateral MNOD. So in quadrilateral MNOD, but before that we have also rule number 2 that states that the sum of the angles in any quadrilateral equals to 360 degrees. Okay, according to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. I'll repeat on rule number 2 again. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. So here, if we focus on quadrilateral MNOD, the sum of its angles must be equal to 360 degrees. So we will focus on quadrilateral MNOD. And according to rule number 2, the sum of its angles must be equal to 360 degrees. So in quadrilateral MNOD, we have 3 right angles, 1, 2, 3. And the sum of 3 right angles is 90 times 3 is 270 degrees. So 270 degrees plus the size of the 4th angle that we will define as angle X must be equal to 360 degrees according to rule number 2 that states that the sum of the angles in any quadrilateral equals to 360 degrees. I will repeat again. The sum of the angles in quadrilateral MNOD equals to 360 degrees according to rule number 2. Therefore, the sum of 3 right angles is 270 degrees. plus the size of the fourth angle must be equal to 360 degrees according to rule number 2. Here we will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees. That is to say, it equals to 90 degrees. So we found out that angle X is a right angle. It equals to 90 degrees. So here, angle X is a right angle. It equals to 90 degrees. So here, as you can see from the drawing, all three angles of quadrilateral M, D, and O are right angles. They are equal to 90 degrees. And we also have rule number 3. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle if not a square. So I will read rule number 3 again. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle if not a square. And here, quadrilateral MNDO has four right angles. 1, 2, 3, 4. Therefore, we will relate to quadrilateral MNDO as a rectangle. Okay? And we have also rule number 4. According to rule number 4, the opposite sides of a quadrilateral, the opposite sides of a rectangle are equal to each other. I repeat on rule number 4 again. According to rule number 4, the opposite sides of a rectangle are equal to each other. It means that in rectangle MNOD, MN equals to DO and MD equals to NO. And we know that MN is the radius of the small circle, that is to say MN equals to R. So here MN equals to R, and according to rule number 4, Mn equals to dO. Mn equals to dO, according to rule number 4, that the opposite sides of a rectangle are equal to each other. And we know that Mn equals to R, so Mn equals to R. So from this equality, we will conclude that dO also equals to R. dO equals to R. So we can write here that dO equals to R. dO equals to R. And what is the value of CO? CO is the radius of the middle circle. Therefore, CO equals to 2 units because it is the radius of the middle circle. So CO equals to 2 units. We can write here that CO equals to 2 units. And we know that dO equals to R. So CO minus dO equals to CD. Okay, again, CD equals to CO minus dO. So CD equals to CO minus dO. Okay, CO minus dO equals to CD. So CD equals to CO, that is 2 units, and dO is R. So in total we found out that CD equals to 2 minus R. CD equals to 2 minus R. Okay, CD equals to 2 minus R. And we have already found out that MC, that is the distance between the centers of the two radiuses, MC equals to R plus 2. MC equals to R plus 2. So MC equals to R plus 2 and CD equals to 2 minus R. In the next step, we will focus on the right triangle, triangle CDM. So on the right triangle, triangle CDM, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, we will implement the Pythagoras theorem on the right triangle, triangle CDM. The square of the hypotenuse is CM, and the square of the hypotenuse is CM squared, equals to the sum of the squares of the perpendiculars, equals to CD squared plus MD squared, equals to CD squared plus MD squared. I will repeat again. In the right triangle, triangle CDM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. that is to say cm squared equals to cd squared plus md squared. But we have already found out that cm equals to r plus 2, so if cm equals to r plus 2, then cm squared will be equal to r plus 2 squared. So r plus cm squared is r plus 2 squared, and it equals to cd squared. We have already found out that CD equals to 2 minus R. If CD equals to 2 minus R, then CD squared will be equal to 2 minus R squared. So CD squared is 2 minus R squared plus MD squared. So in total, we found out that cm squared is r plus 2 squared equals to cd squared, this is actually 2 minus r squared, plus md squared. Here we will open the brackets on both sides of equation number 1, and we will get that r plus 2 squared equals to r squared plus 4 plus 4r, and 2 minus r squared is 4 plus r squared minus 4r plus md squared. So here we have r squared on both sides of equation number 1, so r squared will get cancelled. And we have also 4 on both sides of equation number 1, so 4 will also get cancelled. And what is left from equation number 1 after we cancel those expressions? What is left? It is actually here in this side of equation number 1, we have only 4r and on the other side of equation number 1 we have minus 4r plus md squared. So in total we got that here is minus 4r squared. Okay, it says in total we got that 4r equals to minus 4r plus md squared. Here we will add 4r to this equation, equation number 1, and we will get that 4r plus 4r is 8r, and 4r minus 4r is 0. So what is left here is md squared. So in total we will get that after we add 4r to equation number 1, we will get that 8r equals to md squared. Here we will take a root out of equation number 1, this equation, and we will get that md equals to the square root of 8r. md equals to the square root of 8r according to equation number 1. We know that 8 is 4 times 2, so we will substitute 8 by 4 times 2 in this equation, equation number 1, and we will get that md equals to the square root of 4 times 2 times r. We know that the square root of 4 is 2, so I will write it down. In total we will get that MD equals to 2 times square root of 2R. We found out that MD equals to 2 times square root of 2R. So we can write here that MD equals to 2 times square root of 2R. And okay, so MD equals to 2 times square root of 2R. And we have also rule number 4 that says that the opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO. So MD equals to NO according to rule number 4. I will repeat again. In rectangle MD and O, MD equals to NO according to rule number 4 that the opposite sides of a rectangle are equal to each other. But we have already found out that MD equals to 2 times square root of 2R. MD equals to 2 times square root of 2R. So from this equality, we will derive that NO also equals to 2 times square root of 2R. NO equals to 2 times square root of 2R. So here we can write that NO also equals to 2 times square root of 2R. Okay? So in the next step, we will connect together points M and O by a straight line. And we will also connect together points M and O by a straight line in the original drawing. Then we will connect together points M and A by a straight line. Actually, AM is the radius of the small circle, that is to say it equals to R, and OM is the radius of the middle circle, that is to say it equals to 4 units. OA is the radius of the small circle, that is to say it equals to 4 units, and AM is the radius of the small circle, that is to say it equals to R. And what is the value of MO? From the drawing you can see that MO equals to AO minus AM. AO minus AM equals to MO. Okay, again, MO equals to AO minus AM. But we have already found out that AO equals to 4 and AM equals to R. So we will get in total that MO equals to AO is 4 and AM is R. So in total we found out that MO equals to 4 minus R. So we can write here that MO equals to 4 minus R, and also here MO equals to 4 minus R. Okay? Then we will focus on the right triangle, triangle M and O. On the right green triangle, triangle M and O. On the right green triangle, triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the green triangle is MO, therefore the square of the hypotenuse is MO squared, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to MN squared plus NO squared. So I repeat again, in the green right triangle, triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say MO square equals to MN square plus NO square. We have already found out that MO equals to 4 minus R, so if MO equals to 4 minus R, then MO square will be equal to 4 minus R square. And it equals to Mn square. Mn equals to R, so Mn square will be equal to R square plus NO square. NO equals to 2 times square root of 2R. Therefore, NO square will be equal to 2 times square root of 2R square. So in total we got that 4 minus R square equals to R square plus 2 times square root of 2R square. We will open the brackets on both sides of equation number 2, and we will get that 4 minus R square is 16 plus R square minus 8R, and it equals to R square plus the square of 2 times square root of 2R. 2 square is 4, and the square root of 2R is 2R, and 4 times 2R is 8R. So in total this expression equals to 8R. So here we have R square on both sides of equation number 2, so R square will get cancelled. After we cancelled R square, we will add 8R to this equation, equation number 2. So in this side of equation number 2, we will get that 16 plus 8R minus 8R is 0, equals to 8R plus 8R is 16R. So we got that 16 equals to 16R. We will divide this equation, equation number 2, by 16, and we will get that R equals to 1 unit. We found out that R, the radius of the small circle, equals to 1 unit. So we can write here that R equals to 1 unit. The radius of the small circle equals to 1 unit. Here R equals to 1 unit. And CD equals to 2 minus R, and R is 1. So CD equals to 2 minus 1, that is to say it equals to 1. CD equals to 1 unit. MC is R plus 2 and R is 1. So MC equals to 1 plus 2, that is to say it equals to 3 units. MC equals to 3 units, CD equals to 1 unit. Okay, so in the next step, we'll focus on triangle, the right triangle, triangle CY, and on the right triangle, triangle CDM, and we will prove that those two right triangles those two right triangles are similar to each other. So we will focus on the green right triangle, triangle CEY, and on the right triangle, triangle CDM. And we will prove that they are similar to each other. So first of all, we know that those two angles, they are equal to each other, they are both right angles. So this angle that is actually angle CY equals to this angle that is actually angle CDM in triangle CDM. And both those two angles are right angles, that is to say they are equal to 90 degrees. I repeat again, angle CEY equals to angle CDM, or angle CY from triangle CY equals to angle CDM from triangle CDM, and both angles are right angles, that is to say they are equal to 90 degrees. And we also know that this angle, angle C, is a common angle. It belongs to both triangles. It belongs to the green triangle, triangle CEY, and the angle C also belongs to the right triangle, triangle CDM. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. I repeat again. Angle C equals to angle C. It is a common angle that belongs to both triangles. And finally, we have those two angles. They are equal to each other according to third angle theorem. So this angle that is actually angle CYE from triangle CYE equals to this angle that is actually angle CMD from triangle CDM, and they are equal to each other according to third angle theorem. So I'll repeat again, angle CYE equals to angle CMD according to third angle theorem. So what is third angle theorem? Third angle theorem is that says that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we actually proved that those two angles, they are equal to each other. So those are the first pair of angles that are congruent. And this angle equals to itself. So this is the second pair of angles that are congruent in those triangles. So we have in those two triangles two pairs of angles that can go into each other. Therefore, according to third angle theorem, the third pair of angles, those angles that are defined as the first pair of angles, must also congruent, that is to say, angle CYE equals to angle CMD. Okay, so that is actually the third angle theorem. So we actually proved that all three angles in the green triangle can go into all three angles in the right triangle, triangle CDM. Therefore, we actually proved that triangle CYE, the green triangle, is similar to the right triangle, triangle CDM, according to angle similarity rule. So I will write it down. We actually proved that triangle CYE is similar, this is the sign of similar, to triangle CDM, according to angle similarity rule. I will repeat again. We actually proved the triangle CYE is similar to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles of another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDE, we will conclude that the following equality is true. We will actually conclude that CE over CY in triangle CYE, the green triangle, equals to CD over CM in the right triangle, triangle CDM. Okay, so I write it down. We will conclude that CE over CY in the green triangle equals to CD over CM in triangle CDM. I will repeat again. From the fact that triangle CY is similar to triangle CDM, we will conclude that CE over CY in triangle CYE equals to CD over CM in triangle CDM. So actually CE over CY. What is CY? You can see here that CY is the radius of the middle circle, that is to say it equals to 2 units. So CY equals to 2 units. And what is the value of CD? You can see here, we have already found out that CD equals to 1 unit. CD equals to 1 unit. And what is the value of CM? We have already found out that CM equals to 3 units. 3 units. So in total, we found out that according to equation number 3, CE over 2 equals to 1 over 3. Here we will multiply equation number 3 by 2, and we will get that CE equals to 2/3. C equals to 2/3 according to equation number 3. C equals to 2/3. So here CE equals to 2/3, and what is the value of DE? From the drawing you can see that DE equals to CD minus CE. DE equals to CD minus CE. I'll repeat again. DE equals to CD minus CE. So DE equals to CD is 1 and CE is 2/3. So DE equals to 1 minus 2/3. 1 minus 2/3 is third. So we found out that DE equals to third. DE equals to third. So we'll write here that DE equals to third. And what is the value of line segment OE? The value of line segment OE, it is actually equals, from the drawing you can see that OE equals to OD plus DE. OE equals to OD plus DE. I will repeat again. OE equals to OD plus DE. But we have already found out that we know that OD equals to 1. It is the radius of the small circle, and we have already found out that DE equals to third. So in total, OE equals to 1 plus third. 1 plus third equals to 4/3. 4/3. OE equals to 4/3, or 4/3 units. So we can write here that OE equals to 4/3 units. Okay, so in the next step we will join points O and B by a straight line. And what is OB? From the drawing you can see that OB is the radius of the semicircle, that is to say it equals to 4 units. And in the next step we will find out the size of angle OEB. We will find out the size of this angle OEB. Okay. Here I will present a new rule. Rule number 5 states that the sum of the angles on one side of a straight line equals to 180 degrees. The sum of the angles on one side of a straight line equals to 180 degrees. I will repeat again. Rule number 5 states that the sum of the angles on one side of a straight line equals to 180 degrees. And here we will implement rule number 5 in our drawing. CO is the radius of the middle circle. CO is the radius of the middle circle is absolutely a straight line. So if we focus on the straight line CO, on this side of the straight line CO at point E, the sum of its angles must be equal to 180 degrees according to rule number 5. So what are the angles at point E and on this side of the straight line CO? We have this angle that is a right angle, that is to say it equals to 90 degrees, and plus this angle that is actually angle OEB, angle OEB, so the sum of those two angles must be equal to 180 degrees according to rule number 5, that the sum of the angles on one side of a straight line equals to 180 degrees. Okay, so according to rule number 5, the sum of the angles on one side of the straight line CO at point E must be equal to 180 degrees, and at point E we have one angle is a right angle and the other angle is angle OEB, and the sum of those two angles must be equal to 180 degrees according to rule number 5. Here we will subtract 90 degrees from this equality, and we will get that angle OEB equals to 180 degrees minus 90 degrees equals to 90 degrees. So we found out that angle OEB is a right angle, it equals to 90 degrees. So this angle is a right angle, it equals to 90 degrees. So here, actually, if angle OEB is a right angle, then triangle OEB is a right angle. This triangle OEB is a right angle. So I will draw again the right triangle OEB, and we will find out the length of angle of side EB. Okay? So I draw again the right triangle OEB. We have already found out that side OE equals to 4/3 units, and OB is the radius of the semicircle, that is to say it equals to 4 units. And the only thing that is left to find is to find out the length of side EB, of the right triangle OEB. So according to the Pythagoras theorem, in the right triangle OEB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse in triangle OEB, right triangle OEB is OB, so the square of the hypotenuse is OB squared. and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OE squared plus EB squared. I will repeat again. In the right triangle, triangle OEB, according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, it means that in the triangle, the right triangle, triangle OEB, OB square equals to OE square plus EB square. But we know that OB equals to 4 units, so OB square will be equal to 4 square. 4 square is 16. So 16 equals to OE square. OE equals to 4 over 3, so OE square will be equal to 4 over 3 square. Plus EB square. So here OB square is 16 and OE square is 4 over 3 square plus EB square. Here 4 over 3 square is 16 over 9, so I'll write it down. We will get that 16 equals to 16 over 9 plus EB square. Here we will subtract 16 over 9 from equation number 4, this equation, and we will get that 16 minus 16 over 9 equals to EB square. Here we will multiply 16 by 9 and then we will divide it by 9 in order to have a common factor with minus 16 over 9. So we will get that 16 times 9 over 9 minus 16 equals to EB square. Sixteen times 9 minus 16 is 16 times 8, so I will write it down. Sixteen times 8 over 9 equals to EB square. So in total, we got that 16 times 8 over 9 equals to EB square. 16 is 2 times 8, so we will substitute 16 by 2 times 8, and we will get that 2 times 8 times 8 over 9 equals to EB square. Here we will take a root out of equation number 4 and we will get that EB, according to equation number 4, EB equals to the square root of 2 times 8 times 8 over 9. So EB equals the square root of 8 times 8 is 8 and the square root of 9 is 3. So in total we will get that 8 over 3 times square root of 2 equals to EB. So we found out that EB equals to 8 over 3 times square root of 2 units. Okay, EB equals to 8 over 3 times square root of 2 units. So in the next step we will prove that those two right triangles can go into each other. So we prove that the right triangle, triangle OEB, can go into the right triangle, triangle OEA. So I will draw again those two right triangles and we will prove that they can go into each other. Okay? So we will prove that the right triangle, triangle OEA can go into the right triangle, triangle OEB. Okay? So first of all, we know that OA equals to OB equals to 4 units. OA equals to OB equals to 4 units. And we also know that OE is a common side, it belongs to both triangles, so we can write down that OE equals to OE. It's a common side that belongs to both triangles. By proving those two things, we actually proved that the right triangle, triangle OEA, congruent, this is the sign of congruent, to the right triangle, triangle OEB. And we proved that those two right triangles can go into each other according to rule number 6. What is rule number 6? Actually, rule number 6 states that if the hypotenuse and a perpendicular of one right triangle congruent to the hypotenuse and a perpendicular in another right triangle, then the two right triangles can go into each other. I'll read rule number 6 again. Rule number 6 states that if the hypotenuse and a perpendicular of one right triangle congruent to the hypotenuse and the perpendicular in another right triangle, then the two right triangles can go into each other. And here we actually proved that the hypotenuse OB and the perpendicular OE in the right triangle OEB is congruent to the hypotenuse OA, and the perpendicular OE in the right triangle OEA. Therefore, we proved that those two right triangles can go into each other according to rule number 6. Okay? And from the fact that those two right triangles can go into each other, we will conclude that AE equals to EB. AE equals to EB. AE equals to EB. And AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, the two corresponding sides AE and EB are equal to each other. That is to say, AE equals to EB. And what is the value of AB? From the drawing you can see that AB equals to AE plus EB. AE plus EB. Okay, you can see from the drawing that AE equals to AB equals to AE plus EB. But we have already found out that AE equals to EB, so we can substitute AE in this equality by EB. So we will substitute it and we will get that AB equals to EB plus EB. AB equals to EB plus EB. That is to say, AB equals to 2 times EB. But we have already found out that EB equals to 8 over 3 times square root of 2 units. So in total we found out that AB equals to 2 times 8 is 16. AB equals to 16 over 3 times square root of 2 units. Or in terms of numbers, AB equals to 7.54 units. I repeat, AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. And in the drawing, you can see that AB the length of chord AB is actually equals to 16 over 3 times square root of 2 units, or in terms of numbers, the length of chord AB, it is actually 7.54 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the length of chord AB. And we have here a semicircle, and inside this semicircle we have two small circles that are identical, and the middle circle is tangent to this semicircle at point O. Point O is the center of the semicircle, and point C is the center of the middle circle. And we know that PQ that is the diameter of the semicircle, equals to 8 units. Therefore, the radius will be equal to 4 units. PO, that is the radius of the semicircle, equals to 4 units. And OQ also equals to 4 units. And OX, that is also the radius of the semicircle, equals to 4 units. But OX, it is not only the radius of the semicircle, but it is also the diameter of the middle circle. And if the diameter equals to 4 units, then the radius of the semicircle will be equal to 2 units. That is to say, CX equals to 2 units, and the radius OC of the middle circle will be also equal to 2 units. and CY, that is also the radius of the middle circle, equals to 2 units. Then we join points M and C together by a straight line. R is the radius of the small circle, and 2 is the radius of the middle circle equals to 2 units. So in total MC equals to R plus 2 units. Then we defined the center of this semicircle of this small circle as point M, and we join points M and N together by a straight line. Point M is the point of tangency of tangent PQ with this small circle, and we have the radius MN that is drawn to the point of tangency. Therefore, the tangent PQ is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, the radius CO of the middle circle is drawn to the point of tangency, that is to say it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. And because of the fact that the radius CO is drawn to the point of tangency, therefore the tangent PQ is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, then from point M I drew perpendicular to CO. So the perpendicular CO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees, and the touching point between the perpendicular M and the radius CO is at point D. Then I drew again the perpendicular, the quadrilateral MNOD and the right angle MCD. We got this drawing. Okay, and then we actually calculated the radiuses, the angles of those two. We calculated the angle of this triangle and the angle and this angle also, according to rule number 1, that corresponding angles between parallel lines are equal to each other. And we know that AB is parallel to PQ. AB is parallel to PQ. Therefore, those two corresponding angles that are located between the parallel lines AB and PQ will be equal to each other. That is to say, this angle that is 90 degrees will be equal to this angle that is actually angle CEA. Angle CY. It is the same, angle CY. So 90 degrees equals to angle CY. So we found out that angle CY equals to 90 degrees according to rule number 1. Likewise, we have rule number 1 that can be implemented on those two angles, because those two angles are corresponding angles that are located between the parallel lines AB and PQ. Therefore, they are equal to each other according to rule number 1. But this angle is the right angle, it equals to 90 degrees. So this angle that equals to 90 degrees equals to angle CEB. So in total we found out that angle CEB is the right angle, it equals to 90 degrees according to rule number 1. So we found out that those two angles are both right angles according to rule number 1. Then we have also rule number 2 that states that the sum of the angles in any quadrilateral equals to 360 degrees. And if we focus on quadrilateral MNOD, according to rule number 2, the sum of its angles, the sum of its 4 angles, must be equal to 360 degrees. A quadrilateral MNOD has 3 right angles, 1, 2, 3. And the sum of the 3 right angles is 270 degrees. So 270 degrees plus the size of the 4th angle, that is angle X, must be equal to 360 degrees according to rule number 2. 270 degrees plus the size of angle x must be equal to 360 degrees in quadrilateral MNOD according to rule number 2. We subtracted 270 degrees from this equality and we got that angle x equals to 90 degrees. Angle x equals to 90 degrees. So this angle is a right angle, it equals to 90 degrees. So we actually found out that all three angles in quadrilateral MNOD are right angles. And we have also rule number 3 that states that any quadrilateral that has 4 right angles must be equal. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So quadrilateral MNOD is at least a rectangle. And we will relate to quadrilateral MNOD as a rectangle. And we also have rule number 4. We have also rule number 4 that states that the opposite sides of a rectangle are equal to each other. And we know that MN is the radius of the small circle, it equals to R. And according to rule number 4, MN equals to DO. MN equals to DO, but we know that also that MN equals to R. So from this equality, we will conclude that DO also equals to R. So here, DO equals to R. Then, what is the value of CD? We know that DO equals to R. CO is the radius of the middle circle, it equals to 2 units. CO equals to 2 units, this is the radius of the middle circle. So actually, CD equals to CO minus DO. CD equals to CO minus DO. So CD equals to CO, that is 2 units, minus DO, that is R. So in total we found out that CD equals to 2 minus R. Here CD equals to 2 minus R. And what is the value of MC? MC, we already found out that MC equals to 2 plus R. Okay, then we focused on the right triangle CMD. According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is, the hypotenuse is CM, so the square of the hypotenuse is CM square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CD square plus MD square. CM equals to R plus 2, so CM square will be equal to R plus 2 square. CD equals to 2 minus R, so CD square will be equal to 2 minus R square plus MD square. We open the brackets on both sides of equation number 1 and we got that R plus 2 square equals to R square plus 4 4R, and 2 minus R square equals to 4 plus R square minus 4R plus MD square. Here we have R square on both sides of equation number 1, so R square will get cancelled. And we have also 4 on both sides of equation number 1, so 4 will also get cancelled. So 4 also will get cancelled. And what is left from equation number 1 after we cancel those expressions, what is left in this side is 4R, and the other side is minus 4R plus dm square, md square. So we got 4R equals to minus 4R plus md square. We added 4R to this equation number 1. 4R plus 4R is 8R. Minus 4R plus 4R is 0, so in total we got that 8R equals to md square. We took a root out of this equation number 1, and we got that md equals to the square root of 8R. 8 is 4 times 2, so we substituted 8 in this equation number 1 by 4 times 2, and we got that md equals to the square root of 4 times 2 times R. We know that the square root of 4 is 2, so in total we got that md equals to 2 times square root of 2R. So md equals to 2 times square root of 2r. And we have rule number 4 that states that the opposite sides of a rectangle are equal to each other, that is to say MD equals to NO. According to rule number 4, MD equals to NO, but we have already found out that MD equals to 2 times square root of 2R. So from this equality we will conclude that NO also equals to 2 times square root of 2R. So if NO equals to 2 times square root of 2R. Okay, then we connected together points M and O by a straight line. Here we also connected together points M and O by a straight line. And then we connected together points A and M by a straight line. AM, it is actually the radius of the small circle. AO is the radius of the semicircle, it equals to 4 units. So MO equals to AO minus AM. MO equals to AO minus AM. We know that AO equals to 4 units and AM equals to R. So in total we got that OM equals to 4 minus R. So we can write here that OM equals to 4 minus R. And here also OM equals to 4 minus R. And we have already found out that MN equals to R. And NO equals to 2 times square root of 2R. So we focused on the green right triangle MNO. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OM and the square of the hypotenuse is OM square. It equals to MN square plus NO square. According to the Pythagoras theorem, MO equals to 4 minus R, so MO square equals to 4 minus R square. And it equals to MN square. MN equals to R, so MN square equals to R square. NO equals to 2 times square root of 2R, and NO square will be equal to 2 times square root of 2R square. We open the brackets of this equation number 4, and we got that 4 minus R square equals to 16 plus R square minus 8R. And it equals to R square plus 8R, because the square of 2 times square root of 2R is 8R. So here we have R square on both sides of equation number 2. So R square will get cancelled. After we cancelled R square, we added 8R to this equation number 2. 8R minus 8R is 0. So here we left only with 16. And 8R plus 8R is 16R. So in total we got that 16 equals to 16R. Here we divided the equation number 2 by 16 and we found out that R equals to 1 unit. So the radius of the small circle equals to 1 unit, R equals to 1, R equals to 1. And here CD equals to 2 minus R and R equals to 1. So CD equals to 2 minus 1, that is 1. So CD equals to 1. And then we focused on the right triangle CY, this green triangle CY, this green right triangle, and the right triangle CDM. And we proved that those two right triangles are similar to each other. Why they are similar to each other? Because first of all we have those two angles that are equal to each other. They are both right angles. So angle CY equals to angle CDM equals to 90 degrees. Then we have this angle that is a common angle. It belongs both to the green triangle and then also it belongs to the right triangle CDM. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. And we also know that those two angles are equal to each other according to third angle theorem. That is to say, angle CYE equals to angle CMD according to third angle theorem. What is third angle theorem? Third angle theorem states if two angles in one triangle can join to two angles in another triangle, then the third pair of angles must also congruent. And here we have the first pair of angles that congruent and the second pair of angles that congruent. So we have here two pairs of angles that congruent to each other in those two triangles. Therefore, this third pair of angles must also congruent, that is to say angle CYE equals to angle CMD. So according to third angle theorem, those two angles are equal to each other. So we actually proved that all three angles of the green triangle congruent to all three angles of the right triangle, triangle CDM. Therefore, we proved that those two right triangles are similar to each other according to angle similarity rule. We proved that the triangle CYE is similar to triangle CDM according to angle similarity rule. And what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then you actually proved that those two triangles congruent to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDE, we will conclude that the following equality is true. We will conclude that CE over CY in triangle CYE equals to CD over CM in triangle CDM. Okay, CE over CY in the green triangle equals to CD over CM in triangle CDM. CE over CY. CY is the radius of the middle circle, that is to say it equals to 2 units. CD, we already found out that CD equals to 1 unit. And CM, MC equals to R plus 2 and R is 1. So CM equals to 1 plus 2, that is 3. So CM equals to 3 units. CD equals to 1 unit, CM equals to 3 units. So in total we found that CE over 2 equals to 1 over 3. Here we multiplied equation number 3 by 2 and we got that CE equals to 2/3. So here CE equals to 2/3 and CD equals to 1 unit. Therefore DE equals to CD minus CE. DE equals to CD minus CE and CD equals to 1 and CE equals to 2/3. So in total DE equals to 1 minus 2/3. That is to say DE equals to 2/3. So we found out that DE equals to 2/3. And what is the value of OE? The value of OE equals to OD plus DE. OE equals to OD plus DE. OD is 1 and DE is 1/3. So in total we found out that OE equals to 1 plus 1/3. That is to say OE equals to 4 over 3 units. So OE equals to 4 over 3 units. Then we have we actually connected points O and B together by a straight line. OB is the radius of the semicircle, that is to say it equals to 4 units. Then we calculated the size of angle OEB. Here we calculated the size of this angle. OC is a straight line, and we have rule number 5. The sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on this side of the straight line OC at point E, the sum of the angles must be equal to 180 degrees. What we have at point E, we have 90 degrees plus angle OEB must be equal to 180 degrees according to rule number 5. So here 90 degrees plus angle OEB must be equal to 180 degrees according to rule number 5. We subtracted 90 degrees from this equality and we found out that angle OEB equals to 90 degrees. So angle OEB equals to 90 degrees. If angle OEB equals to 90 degrees, then triangle OEB is a right triangle. Triangle OEB is a right triangle, so I draw triangle OEB again. And we know that OE equals to 4 over 3 units, and OB is the radius of the semicircle, that is to say it equals to 4 units, and we found out the value of EB according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say OB square equals to OE square plus EB square. OB equals to 4, so OB square is 4 square, 4 square is 16. Plus OE is 4 over 3, so OE square is 4 over 3 square plus EB square. So in total we got that 16 plus 4 over 3 square is 16 over 9. So 16 equals to 16 over 9 plus EB square. We subtracted 16 over 9 from this equation, and we got that 16 minus 16 over 9 equals to EB squared. Here we multiplied 16 by 9 and then we divided it by 9 in order to overcome a factor with minus 16 over 9. And in total we got that 16 times 9 minus 16 over 9 equals to EB squared. 16 times 9 minus 16 is 16 times 8. So in total we got that 16 times 8 over 9 equals to EB squared. We know that 16 is 2 times 8, so we substituted 16 by 2 times 8 in this equality. In total we got that 2 times 8 over 9 equals to EB squared. Here we took a root out of equation number 4, and we got that EB equals to the square root of 2 times 8 over 9. The square root of 8 times 8 is 8, and the square root of 9 is 3. So in total we got that EB equals to 8 over 3 times square root of 2 units. Okay? And then we actually proved that those green right triangles can go into each other. Why they can go into each other? I actually drew again the right triangles, and we proved that those two right triangles can go into each other. Why they can go into each other? Because of the fact that OA equals to OB equals to 4 units, and OE is a common side, it belongs to both triangles, so OE equals to OE is a common side that belongs to both triangles. By proving those two things, we actually proved that triangle OEA is congruent to triangle OEB according to rule number 6. And what is rule number 6? Rule number 6 states that if the hypotenuse and a perpendicular of one right triangle congruent to the hypotenuse and the perpendicular in another right triangle, then the two right triangles can go into each other. And we actually proved that the hypotenuse OB and the perpendicular OE in the right triangle OEA can go into the hypotenuse OB and the perpendicular OE in the right triangle OEB. Therefore, we proved that those two right triangles can go into each other according to rule number 6. And from the fact that those two right triangles can go into each other, we will conclude that AE equals to EB. AE equals to EB. AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, the two corresponding sides AE and EB will be also equal to each other. That is to say, AE equals to EB. And what is the value of AB? The value of AB, you can see from the drawing that AB equals to AE plus EB. AB equals to AE plus EB. But we know that AE equals to EB, so we can substitute AE by EB. So we substituted AE by EB, and we got that AB equals to EB plus EB, that is to say AB equals to 2 times EB. And we already found out that EB equals to 8 over 3 times square root of 2 units. So in total we got that AB equals to 8 times 2 is 16. So in total AB equals to 16 over 3 times square root of 2 units. Or in terms of numbers, AB equals to 7.54 units. So here, in the original drawing, we can see that the length of AB, we found out that the length of chord AB equals to 16 over 3 times square root of 2 units, or in terms of numbers, the length of chord AB equals to 7.54 units. Okay? Thank you very much.